I guess let me catch up to you. The slope, so you could do 7 minus 5, the difference in the y's. And now you go the same way with the x's, negative 2 minus 4. So I get 2 over negative 6, which is negative 1/3. So that's going to be my m. So I got my m value. And now you just got to pick a point. So some of you guys, I don't know, who picked negative 2/7? Anybody? Nobody liked that one.
No.
Who picked 4 or 5? who didn't do this problem?
I picked 4 or 5.
Yeah? Who did this problem? All
I
right.
didn't simplify it actually, but I still got the right answer.
How do you mean simplify?
I didn't simplify 2 over 6.
Oh, okay. Eventually you did, believe it or not. Yeah. You reduce now or you reduce later.
Okay.
Yeah. So I'm going to pick, just randomly, I'll pick 4 or 5. So if I do y minus the y piece
Sorry, 5.
equals the m I found times x minus the x piece.
4.
So y minus 5 equals negative 1/3 x plus
4.
4/3. And then I have to
Plus 5.
add 5. So you go y equals negative 1/3 x. That'll be 15 over 3, so it'll be 19/3. Wow. Now, if you use the point negative 2/7, you have to come out to the same thing if you did it right. Doesn't matter which point you use, you can use any point on the line, and we know 2 points on the line, so you can use either one. I like it. Alright, so that's the idea behind this equation, where it came from, and how to use it. So there are several problems in the homework for section 3.3 that deal with using this equation. Let's see. Now I want to get into something. Let me define a few terms they use in this section. Something called scatter plot. So here's how to do a scatter plot. They're going to give me a bunch of points. So a scatter plot is just plotting all those points. It's almost too nice to believe. So the word scatter plot just means plot a bunch of points. And these points could have been, I'm at some research station in the Arctic Circle, and I go out every hour. So the first recording I made, it was negative 1 degree Celsius. And then the second recording I made, it was negative 5 degrees Celsius. And, here's the second, it's still negative 1, and then it went colder, and then it got colder, and then it got colder, right? So I'm like, oh, shit. You guys kind of with me? I mean, so these points come from physical observations that we make. So what we're doing is we try to plot these so that we can make predictions about what's going to happen. So if I, for example, take the temperature of the Earth over time, I can make predictions about what's going to happen. You can get into the politics of it and the science denial of it, but this pure, straight facts to show you, oh shit, we get some trouble. I don't care who's making something happen. So here, just to do a scatter plot, you just plot these points on a number line, on an XY plane. Looks like my y-axis has to go down pretty far, so I'm going to make my y scale maybe by 2. This is a choice you can make. And then my x scale, I'm just going to make it go by 1. It's got to go up to 7 again, so let's make it 2 also. Cool. And then you just plot points. 2, negative 5. 4, negative 7. 0, negative 1. 1, negative 1. 7, negative 11. So what you say is the trend in the temperature at my Arctic Research Center?
It's gradually getting lower.
Yeah, it's decreasing. The temperature is decreasing over time. So that's the trend that I see is a decrease in temperature. That's pretty obvious. It's in your face, right? So very strong. Would you say, I was about to tell you this, but would you say it's a strong relationship between time changing and temperature decreasing? Is that a strong relationship? Because it almost makes a perfect straight line if it only wasn't for this little point, and a couple of these aren't quite lined up, but I can draw a pretty straight line and it almost goes through a lot of the data points. So it kind of makes sense that the weaker the connection is, the more spread out the points should be away from the line. Does that make physical sense? The closer they are to the line, the stronger the correlation is. The further from the line they are, the weaker the correlation is. I like it. So we're gonna use these data points here in a minute. Let me give you this little handout. Focus on the side that's got a bunch of dots on it first.
You have to try this first experiment.
It's totally up to you. I'm not condoning or suggesting you do this. If you have a 7 a.m. class, oh my god. So those exist. I taught like a 7:25 a.m. class once, and so if you have a 7 a.m. class and you go out the night before, you go drinking, as we often do. Obviously, hopefully you understand, the number of beers you have the night before might have an effect on how you do on the test. Let's start there. Is that reasonable to say? I mean, if you have a ton of beers and you can't really, you're not like some superhuman able to handle all that much liquor, then the next morning you're probably not going to be functioning at your best. Is this understood? So you probably could have done better on the test if you wouldn't have done that, right? But which one of these is more realistic? Which one is more realistic? This one says, let's start here. Which one of these is stronger? The relationship is stronger. This one, because they line up pretty well, right? So it's very lockstep. You drink half more beer and your grade goes down, and you drink half more beer and your grade goes down. Holy crap, that's like lockstep. But which one is more realistic?
Left.
You see, my laser. Ooh, my laser works. Who is this person? Did they drink a lot of beer relative to everybody else?
No.
No, right? Their number of beers is low, but their grade is low. So that's the person that doesn't understand it, so no matter how many beers they drink, it's not going to affect what they're going to do. Who is this person here?
Wasted.
Yeah, they got pretty drunk, but they seem to be one of these people that don't get hangovers, maybe. And they're able to handle a lot of alcohol. You guys, there are people out there. Some of you guys might be that person. Might be that person. These two are outliers. So that's going to happen in the real world, obviously. There's going to be different fluctuations and different things that affect things. Here we're only looking at two variables. How do beers affect your grade the next morning? But if I kind of discount those two outliers, doesn't this data line up pretty decently, not as strong as this guy, but more realistically. Is that cool? Now tell me this, if I drew a line in, it would be like sort of like this, would that line have a positive or a negative slope? Negative. So the correlation would be negative, which means as one of these things increases, the other one decreases. That's what a negative correlation would mean. It actually means there will be a negative slope. I like it. I like it. All right. So looking at a positive correlation would be the hours you study. I don't want to do that. Stop it. Where's my laser? Okay. Again, this one would be a stronger relationship, but this one is the one that's more realistic. Who is this poor person here? Same scale as the other one, by the way. Who is this poor person here? They studied a lot, but the grade was low. And that's the kind of person I think that doesn't know how to study. They're not sure what the word study means. They do something for a long period of time, but it's not really study. And who is this person there?
Smart.
They barely studied at all, but they got this huge grade, which either means they just know the shit really well already, or they take in the class again. I mean, that's what I try to remind people. They don't even do anything, and they're getting high grades. They might have taken this class before. And we haven't hit the part that they freaked out on the first time they took it. So don't worry about what the hell other people are doing around you. It doesn't matter anything to you. All right. So this is more realistic, but less strong. It's a weaker relationship. But they both would be positive correlations. They both would have, from your perspective, positive slopes. How are we doing so far? Is that cool? Okay. So there's two things we can get from this stuff mathematically. We can get this number, we give it the symbol R. It stands for regression, really, but it's called the correlation coefficient or the Pearson product. And of course, my stats teacher, his name was Mr. Pearson, so, but he had nothing to do with this. But he liked to pretend like he did. We use the symbol R. So if R is 0, that means no correlation at all. It would mean like, for example, let me put it up here. I have to turn my camera all the time. So if R is 0, it would mean something like this. There's no line I could draw. It doesn't look like it's increasing or decreasing. It's all over the damn place. You guys kind of with it? R equals 1 would be perfect positive correlation. They all line up and every single data point is on the line. That's perfect positive. So amazingly enough, R equal -1 would be down. R equals 1 is perfect positive correlation. So R equals -1 would be perfect negative correlation. So very few things in the real world are perfectly correlated. So there's going to be something away from 1. It's going to be a little bit away from the straight line. So let's do this. Let me first, if you look on the back here, I got a ton of instructions. So let me run you through this once. Oh, joy. Oh, if you need to borrow a graphing calculator, there's someone right there. Let's see. Or you're just going to watch. Okay, sure. You can do that too. If you need to borrow a calculator, they're right there. I'm going to use this data here for the number of beers I drank and the grade that I get on the test the next morning. So you guys see that data on the back of your handout? So let me switch this over to the calculator real quick. So this is kind of nifty. So if you hit that stat button right here, you're you can then use the edit button to put data into this calculator. So if I hit the edit button, I'm going to edit the lists of data that it wants to use. So let me do that. So I get this. I got some stuff in there already. Are you guys, everybody with me? Where is everybody at this point that wants to play along? You guys see these lists? Does everyone have L1, L2, L3? I like it. There's one calculator left if somebody needs it. Okay. So if you go up here, you can go up to like L1 and hit clear. That'll make it nice and empty. Go over to L2 and hit clear. That'll make it nice and empty. So now this is sort of like an XY table now. Don't worry about L3. That's if I had even more data. I could put even more data in there. We only have two things, beers and grades. X is beers, Y is grades. So if I take a minute and just start putting in here the beers, 0.5. You guys see what I'm doing? 0.5, 0.7. Everybody see where those numbers are coming from? From your handout that I gave you, right? Cool. So start doing that if you want to try this along with me. 0.5, 0.71, just keep going. Now next to it, you're going to put in their grades. Data entry is always so exciting. Should make a movie about this right now. What's the next number going to be? Oh my God. Where am I at here? 1.5. Every now and again you can just check, like I should be 2.771, good. 3 is 84, I like it. Okay. So if you're playing along, let me know if you have any difficulties.
Actually, I have no idea what's going on.
Oh, this is why I was asking you at L1, L2. You don't. So you just had to tell me that. Off or a little too. Oh, your battery's just done wrong. This was wrong. Oh yeah, your battery's just gone. Poor little thing, it's freaking way out. Here. Is that mine? No.
It was up there.
Oh, it is mine. So I need to figure out what's wrong with this guy. Oh, I see what you're doing. Alright. Again, how do I get to these lists? I hit stat, short for statistics, stat, edit, and then there's the list where I put my data in. Alright, you don't put it into the y equals. Alright, everybody else okay that's trying to play along? Okay.
Does it matter if it says L4, L5, L6? I couldn't get it to say L1.
Oh, but that's when you tell me.
Okay.
Yeah.
I couldn't like
So there's one little thing, set it better, it'll bring back. So somebody can delete a list, and then the list is gone. So where do you put it in? You put it in L4, L5. So watch this, it's kind of cool. I can say let L1 be L4. Bam. L2 be L5. Bam. Now they're in the right place.
And then just do clear L3.
If you want to, doesn't matter. Alright, everybody who's playing along, you ready? So, do you agree that, now on some of these you might have to actually plot the points yourself, like I did there. Not too difficult. That's a lot of freaking points. And some of them are kind of gross, 1.1 and stuff. So this is a graphing calculator. This should be its bread and butter. This should be the thing it just tackle with no problems. The main thing it does is graph. It's in the title of it. So this is kind of cool. If I go hit second, y equals, to get up in the stat plot. and then I want to turn the first plot on. So you would hit enter, turn this bad boy on. So the stat plot just stands for different types of statistical plots. You guys remember the histogram stuff? And let's see what else. Do we do any bar graph? I can't remember the box whisker plot. This is just the points. That's all I want. It's a scatter plot. I just want a bunch of points. So I want that very first one highlighted. Do you guys see that? So make sure. So let me do this again. Go to stat plot. Make sure this is the only one that's turned on. If it's not turned on, you go in and you highlight on. Highlight this first graph type. And now look, this is why I want to make sure that for you the lists were right. So it should say X list is L1. That's where it's going to get the X piece. That's my number of years. The Y list is L2. So you could put them in different lists. You would just have to change these.
Oh, okay.
And then you get to pick, are you a square? Are you positive? Are you a speck of dust in the universe? I'm a math teacher, so I'm always a square. You guys could be, it's just going to be the symbol it puts on top of all the data points. So if you pick something else, all right, how are we doing so far? So what were the steps so far? Tell the calculator what the data is. That seems important. Secondly, turn on the plot so it'll actually plot the data. That makes sense. Now the third thing is kind of weird. If I just hit graph right now, I'm going to get something very strange. You're going to get something, who knows what you're going to get. I don't see any freaking points. What a jip, Jeff. So two things. Make sure your y equals is empty. See the y equals button right here? That's where you can go and put in there like 4x squared plus 2, and it'll graph 4x squared plus 2 for you. Right, so if you have a y equals equation, you could put it there and it'll graph it for you. Again, graphing calculator, that's what it does, is graphs. But I want this right now, I want this clear. Okay. Now here's the other thing. I put the data in, I told it to make a graph of it, but now I got to tell it to find the data. So that's where I go to zoom. All of this, by the way, is on this handout that I gave you. If I go to zoom, for me it's zoom number 9, zoom stat. So it's going to zoom in on where my data is, zoom in on where my statistics is. So if I do that one, this is going to be, there, I get that. So let me see. Where are we at here? Yeah, the newer ones have colors. It's very nice. Yeah, I've got a newer calculator like this slimmer calculator, or the newer RAM that's going to have colors. You doing all right there, buddy? Yeah, you're about to turn.